Okay, so today we're going to talk about real zeros. Finding the real zeros of a polynomial is the same as solving the related polynomial equation. So we're going to be looking at either factoring by finding zeros, or we're going to look at finding the actual zeros so we're solving an equation. First of all, we want to talk about rational zeros. And rational zeros are when we take the leading coefficient and the constant term and we divide them. And so we have what we call the rational number R over S, or we can use A over B if we want. Rational numbers are numbers that can be written as the ratio of two integers. So our rational zeros are where R is a factor of the constant term and S is a factor of the leading coefficient. So in other words, we're going to take the factors of the constant term, divide them by the factors of the leading coefficient to find the possible rational zeros. Okay? So factors of the numerator are the constant term, factors of the denominator are the leading coefficient. So here we have this function, 4x to the fourth minus 21x cubed plus 18x squared plus 19x minus 6 equals 0. And we want to find the possible zeros. So to find the possible zeros, we're going to take the coefficient of 6, or the factors of 6. So the factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Those are the factors of 6. And those are our values for R, okay, the numerator for our constant term. For S, the factors of the leading coefficient, plus or minus 1, plus or minus 2, and plus or minus 4. So we're going to take the values of R over the values of S, and that's all of our possible rational zeros. So we're going to use these numbers then to write our rational zeros. So those are going to be, so we do all of these numbers over 1, so that means that if I divide 1 by 1, I get 1, 2 by 1, I get 2. So we're going to have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Okay, we have those, right? Then we take each of our values of R and divide them by 2. So we have plus or minus 1/2, plus or minus 2 over 2. All right, so there we have just our 1 again, so we don't need that one because we've already included it. Plus or minus 3 over 2. And plus or minus 6 over 2, which 6 over 2 is going to be, so that would be plus or minus 3. So that's taking each value of R and putting it over 2. And now we'll do each value of R over 4. So we have plus or minus 1/4, plus or minus 2/4, which is 1/2. We already have that one. Then we do 3 over 4, so plus or minus 3 over 4. And then plus or minus 6 over 4. Now 6 over 4 is 3 over 2, so we already have included those also. So these numbers here are all of the possible zeros that we have. Now, before technology and the use of the calculator, we would have to check all of these. Now, first of all, we know the most zeros there could be would be 4 of them because it's a fourth degree polynomial. So we know it can't be all of these. But we know it has to be that any rational zeros we have would have to be some of these numbers. Otherwise, they would just be decimals or radicals. Okay? So the easiest way then to check to see which ones are is we're just going to go ahead, instead of plugging them all in like we would have in before technology, we're going to take out our calculator, put the function in our y equals, and then we're just going to check them that way. So 4x to the fourth minus 21x cubed plus 18x squared plus 19x minus 6. So we put this in our y equals and graph it. So we have this graph here. And when I look at this graph, I'm going to make it a little bit bigger for the moment. And by looking at it, let's zoom in a little bit. We can change our window a little to help us see the numbers a little bit better. Okay. So we know that this is a fourth degree polynomial. And with that fourth degree polynomial, that these are our possible rational functions. So if I go ahead and do, I'm going to check them. So if I look at this one right here, the one that's in the negative, that looks like it might be about negative 3/4. So let me hit trace and negative 0.75. All right, and I got it. So negative 3/4 is one of them. Okay. The one right here, just the other side of 0 looks like it might be 1/4. So let's try 0.25. Okay, nope, that's not one. All right, we have one here. Looks like it's about 2. All right, 2 is a possibility. So I'll try 2. All right, that's 1. So we've got negative 3/4 and 2. So let's write those down before I forget them. Negative 3/4 and positive 2. And let's see, our other one is over here. Let's see, there's 1, 2, 3. It's almost 4. And if I look on my list of numbers here, the possible zeros, I don't have anything near 4. So then that is probably not going to be, or it's not going to be, a rational 0. Okay? So let's take a little bit closer look at that one then. So we've got negative 3/4 and 2. So I have 2 of them that are not rational zeros and 2 of them that are rational zeros. Okay? And so what we're going to look at now is how do I find those other 2? So here's our, says zeros in the factor theorem. So once some zeros of the polynomial have been found, the factor theorem can be used to factor the polynomial, which may lead to additional zeros. Okay? So factor theorem. So let's think about factoring for a moment. If I have zeros at positive 2 and negative 3/4, that means I have factors of x minus 2 and x plus 3/4, which can be written as 4x plus 3. All right, remember that we can take this 4 and slide it there to write it as a factor. So now we have these 2 factors, x minus 2 and 4x plus 3. So we have another factor. And since it's a fourth degree, that's going to be a quadratic. Well, we have 4x to the 4th, so we've got x times 4x is 4x squared. So we're going to have an x squared here. And negative 2 times 3 is negative 6. So this would have to be a plus 1. The thing is I don't know what goes in here in the middle. And so we're going to have to use synthetic division to be able to find what goes in the middle. So we set up our synthetic division. We'll use 2 first, since that's an easier number to work with than 3/4. And put down our coefficients. And so we're going to be doing synthetic division a lot today in our work with finding zeros. So we bring down our 4, multiply, 2 times 4 we get 8. So this gives me negative 13. Times 2 is negative 26. So that gives me negative 8. Times 2 is negative 16. Positive 3 times 2 is, 3 times 2 is 6, and so that's a 0, which it should be. Okay? So now we'll use negative 3/4. Now let's use a different color. So negative 3/4 here. So I bring down the 4. Negative 3/4 times 4 is negative 3. So this is negative 16. And if it works out correctly, all of these numbers in this bottom row should be multiples of 4 to make it easier to simplify. 3/4 times negative 3/4 times negative 16 is going to be 12. Right? 4 goes into 16 4 times, so 4 times 3 is 12. This gives me a 4. Negative 3/4 times 4 is negative 3, and I get 0. So now I have 4x squared minus 16x plus 4. The only thing is with those 3 zeros, or with those 3 terms, they're all multiples of 4, so before I go anywhere else, I'm going to take out that 4. So my missing number up here was negative 4x. Well, this is a quadratic, and they want us to find all the real zeros of this function. So then you can guess what we need to do now is either complete the square with this third factor or use the quadratic formula. So we'll use the quadratic formula to find that. So we've got the opposite of negative 4 over 2 times 1. So we're going to use these numbers here, using those numbers, not the ones with the multiples of 4, because that'll make a lot more work then. Plus or minus the square root of negative 4 squared, and I'm going to run out of room, minus 4 times 1 times 1. Okay, divided by 2 times 1. All right, now I'll write it a little bit bigger over here. So we get 4 over 2 plus or minus the square root of, and we have 16 here, minus 4 is 12 over 2. So 4 over 2 is 2 plus or minus, and the square root of 4, or square root of 12 is 4 times 3, so that's 2 square roots of 3 over 2, and which would be 2 plus or minus the square root of 3. So my zeros then are 2 negative 3/4 and 2 plus or minus the square root of 3. And just remember, we can check them. That we can go to our calculator, and in my trace feature, I can do 2 plus the square root of 3. And there's our 0 there at a little bit at 3.73. And 2 minus the square root of 3 gives us the 0 down here, which is at about 1/4 at 2.67. So there we were able to find all 4 zeros. We found our rational zeros first, and then once we know the rational zeros, we can use factors or use those zeros to do synthetic division. Now, with that, it only works for the synthetic division if we can get it down to a quadratic. If you can't get it to a quadratic, then you want to just go ahead and graph it and find the zeros from your graph. Okay. All right. Irreducible and completely factored polynomials. So we can take polynomials, and we didn't do it here. We didn't completely factor this last one. Okay. We wrote it as x minus 2, 4x plus 3, and x squared minus 4x plus 1. But we could have actually completely factored it by using the square roots here. So this says find all the rational zeros and then write it in factored form. Okay? And so this is a cubic function. If it's not something that you can regularly factor, actually this one we can, but we're not going to do it that way. If you can do it that way and you see it, make sure you do that. But let's imagine in this case that you can't. So go ahead and graph it. So we have 4x cubed minus 8x squared minus x plus 2. So we graph this, and once we graph it, we're looking for rational zeros. So in this case, My rational zeros, looks like it might be plus or minus 1/2 there, possibly. But I can see for sure that there is 1 at 2. So I have a 0 at 2 here. And so by using that 0, and let's think about the other possible zeros, okay? Before we go on, let's focus that way. Um, Remember, my factors of 2 are 1 and 2. Okay, all right. Those are the factors of the constant. And then the factors of the leading coefficient are plus or minus 1, 2, and 4. So if these are my values for R, these are my values for S, then my possible zeros are plus or minus 1 and 2. All right, we found 1 at 2. If I divide both of these by 2, we get plus or minus 1/2. And 2 divided by 2 is 1, which we already have 1. Or plus or minus 1/4 when I divide 1 by 4. And 2 divided by 4 is 1/2, which I've already included them. So these are all my possible rational zeros. And so if I go to back to my graph here, then my possible rational zeros are 1/4 and 1/2. And so when I look at the ones around the x-axis, it looks like I might have some that involve 1/2. So let's see. So let's try negative 0.5. Yep, that's a 0. And, oops, 0.5 is a 0 also. So our zeros are 2 and plus or minus 1/2. Okay? So when we write those in factored form, we would have x minus 2, so f of x equals, and then x plus 1/2 and x minus 1/2. Now, we don't want to leave them in that form because when we multiply, we're not going to get 4x cubed. So I need to take these denominators, move them to the front. So we get x minus 2, 2x plus 1, and 2x minus 1. So there we factored it completely. Okay. All right. Oops. Got to go down here. Okay. Boundaries. Lots of times we have boundaries that we need to deal with because we end up with a polynomial that the degree is really large, but we don't see all the zeros. So we don't know if there's a 0 that lies off the screen of our calculator. So we have to use the bounds test to make sure that there's no more zeros beyond what we can see. And I'm actually going to pause. I'm going to pause the recording. Okay, so we're going to look at bounds test, which we use the bounds test because sometimes we end up with a leading, or our degree of our polynomial is pretty large, like 4th or 5th power. And when we graph it, we might not see that many zeros. So if we don't see that many zeros, we have to be sure there's not a 0 outside of what our window is. So we need to make sure that that is the case. So they have something called the bounds test. And the bounds test is used with synthetic division, that we can use it and with specific results tell whether all of the zeros are between what we can see. So this says if d is greater than 0 and every number in the last row in synthetic division is non-negative. Okay, so if the last row is all positive or 0, then we know that that could be an upper boundary. That means there's no zeros beyond that point going to the right. for larger x values. And it says if c is less than 0, so if we have a 0 that's below, a number below 0, or less than 0, and all of the numbers in the last row alternate from positive and negative, with 0 considered as either, then c is a lower boundary, which means then that there could be no 0 less than that number there. All right, well, let's see how this works. Here we have the function 2x to the fifth plus x to the fourth minus 9x squared plus 4x plus 1. And it says it lies between negative 1 and 2. We want to show that all the zeros lie between negative 1 and 2, and then they want us to find it. So what we're going to do is we're going to use the bounds test first of all. So here's what we do. Negative 1 is below 0. So I'm going to use synthetic division with negative 1. Okay. Notice that there's no x cubed, so I have to remember to put a 0 there. So we bring down our 2, we get negative 2, negative 1, positive 1. Negative 1 times 1 is negative 1, so we get negative 10. Negative 1 times negative 10 is 10, so here's 14. And negative 14 would give me negative 13. So if negative 1 is a lower boundary, that means that there's no real zeros less than negative 1. All of these numbers in this bottom row are going to alternate from positive and negative. And they do. We have positive, negative, positive, negative, positive, negative. So there's no 0 less than negative 1. Okay. And so we'll look at 2, use 2, and see if there's any zeros greater than 2. And if all of these are positive, then they're not. And sometimes you don't even have to do the whole thing. You can see it after a couple of values that they just keep getting bigger and bigger, and there's no way you can get any negatives. So we bring down the 2, we get 4 here. 1 plus 4 is 5. 2 times 5 is 10. 2 times 10 is 20. 2 times 11 is 22. And 2 times 26 is 52, so 53. So since 2, 5, 10, 11, 26, 11, 26, and 53 are all positive numbers, then the upper bounds test works. So that means that all of my zeros are going to be between negative 1 and 2. So let's graph this then and verify that. And remember, that's all the real zeros. There could be some non-real ones outside there, but the real ones for sure are between there. So let's graph this. 2x to the fifth plus x to the fourth minus 9x squared plus 4x plus 1. So if I actually put my window then from negative 1 to 2, now this is a fifth degree polynomial, so I'm looking for 5 zeros. So if I graph this now, all right, we have 1 0, 2 zeros, 3 zeros, and that's it. Okay? But there could be 5 zeros, right? But by using the test I just used, there are no zeros outside of the window screen that I can see. So if I change my window to go from negative 20 to 20, there would only be 3 zeros. All right, so let's see what we get. Okay. Oh, it's even hard to see. Oops, all right. So you can see that by making the window that big, that everything is centered right here in the middle around the x-axis. So there's actually not any off to the right or to the left. I could even make it bigger and see. But I don't need to, because this bounds test tells me, all right, they're all in there. I don't have to look any further. So let me go back to, I'll go zoom 4. And so all of my zeros are here, and they want me to find them. So I know that the only rational zeros are going to be plus or minus 1 or plus or minus 1/2. Okay? Coefficients of 1, plus or minus 1. Coefficients of 2, plus or minus 1 and plus or minus 2. And if I look at my graph here, it doesn't look like -1 is not 1, -2 is not 1, um, and there's none at 1/2. So I'm just going to have to use my zero finder. So the zero finder, second trace, and number 2, and use this zero finder then to find the zeros. So left boundary, so I need to be to the left of this 0 here. That's just to the left of 0. And I can type in -1 there, okay, because that's definitely left of it. And 0 is to the right of it, so I could type in 0 then and hit enter. And I have a 0 at -0.178. So let me capture that. All right, the next 0 is between 0 and 1. So I'll go second trace, number 2. And it says left boundary, so since this 0 is between 0 and 1 here, I could use 0 as my left boundary and 1 is my right boundary. All right, and we get 0.693. And then the last one, do our 0 again, zero finder, number 2. And this one is between 1 and 2, so I could use 1 and 2 as my boundaries. And I get 1.21. So my zeros here are at 1.21, 0.693, and at -0.178. All right, and so we just use the bounds test to show that there are no zeros outside of -1 and 2. And so the only real zeros for this problem are these 3, which means that the other 2, unless there's multiplicity, the other 2 are going to be non-real zeros. So if we were able to do synthetic division with these 3 numbers, we could reduce that down to a quadratic, and then we could do the quadratic formula to find the other 2 are non-real. Okay. All right. So here we talk about the bounds test. Again, it says do synthetic division. Look at the signs of the last row to check for upper or lower boundaries. But it says find all the real zeros. So all of my rational zeros in this case are going to be, the only rational zeros would be plus or minus 1. Because the coefficients of 1 are 1, coefficients of 1 are 1. So once I graph this then, we know that the rational zeros can only be between there, but real zeros could be outside of that. All right, so we've got x to the 5th minus x cubed. And plus 7x squared minus 5x and plus 1. Okay. All right. Oops. Made a mistake somewhere. Oops. There we go. Okay. I'm going to go to Zoom 6 standard viewing window. Okay, and they want us to find all real zeros. So we look at this graph, and looks like there's one here, might be a couple there. But how do I know there's not any out here? So what we can do is pick some numbers between the zeros. So I have a 0 here at about -2.5. So if I pick a number to the left of that, and I do synthetic division, then if all the numbers alternate then from positive to negative, I'm not going to have any more zeros beyond that point. And I would do the same thing on the right. So let's zoom in here a little bit more. So let's go back to zoom 4. Right. So it looks like we have a 0 at a little bit more than -2, and 1 here at about 0.5. Now I can't tell for sure if that one comes below the 0, if there's 2 of them there, or if there's just 1. So I'm going to zoom in a little bit farther if I can see that. So let's see, let's change our window here. And let's go from -1 to 1 here for the y, just to get a little bit closer view of that one. Okay. All right. So it looks like from that, it looks like there might not even be a 0, but I'm sure there's 1 0 there. We'll just have to check it out. All right. So what we need to do, though, is make sure that there's none out here. Okay. So since this one's at a little bit more than -2, let's try -5. Okay. We don't have to use numbers real close to it, but we don't want to use huge numbers either. So we'll do synthetic division with -5. And I'm looking for alternating positive, negative. So we have a positive, -5 times 1 is -5. Okay, so here's a negative. -5 times 5 is 25. So this is going to be a positive, 24. Negative times this positive number is, let's see, that's 120. So that's -113. So then I'm going to get this large positive number, which is basically 500, or 565, okay? And so here's positive 560. Multiply that by a negative, I get this big negative number, so this is going to be negative. So I end up with positive, negative, positive, negative, positive, negative. So there's no zeros below -5, and when I graphed it originally, it didn't look like there were any. This verifies it. Okay? Let's try positive 5 then. Now you don't have to use as big a numbers. You could use smaller numbers, see if it works. If it doesn't, then try a little bit bigger number. And as these get bigger, we can tell that as I multiply this positive number by all these positive numbers I'm going to get. So this is 6, 10. We're just going to keep getting bigger positive numbers. And so since these are all positive, we know there's no 0 larger than 5. Okay? So I can just use my calculator now, find those zeros, use my zero finder. Okay? This 0 here is between -2 and -3, so I can use -3 as my left boundary, and -2 is my right boundary. So my 0 there is at -2.268. And it looks like there might be a 0 over here between 0 and 1, so let's try it there. Left boundary 0, right boundary 1, and okay, there's no sign change there, which means that the graph then does not actually come down and touch the x-axis. So the only real 0 we have in this problem then is going to be here at -2.268. But I know there's none smaller than -5 or larger than 5 either. Okay, our last problem then here. It says find all the real zeros once again. So we could use our look at our possible rational zeros here. Since the coefficient of our leading coefficient is 1, then we would just think about the factors of 12. So 1, 2, 3, 4, 6, and 12. So the only possible rational zeros are those integers. So let's go ahead and graph this, which you're going to be doing a lot of this. Like you can see, already a lot of what we're doing is going to be graphing. And let's zoom out a little bit. All right, so I have a fourth degree polynomial. There looks like there's a 0 at approximately negative 5.5. Looks like there's 1 between 0 and 1. And it looks like there's 1 at 2 also. So let's see. If I go to my table, and I can see that there's 1 at 2. Right? And in the other ones, remember, they have to be whole numbers. So, or integers. Right? So we said that up to 12, negative 12, nope. Okay. And go up to positive 12. Okay. So the only rational 0 I have is going to be here at 2. Right. So let's find the other ones. All right, so we said this one is between negative 5 and negative 6, so my lower boundary could be negative 6, upper boundary negative 5, and we have negative 5.54. There's one between 0 and 1, so we'll find that one. Left boundary 0, right boundary 1, and at 0.541. Now let's zoom in a little bit at 2 and see if what the case is there. So let's change our window. Let's go from 0 to 4, okay, for that one. And we want to make our y scale real small so we can see if this graph actually comes below the x-axis. Okay. And you can see from the graph that at 2, it does not go below the x-axis, so that's my other 0. So my zeros are at my real zeros, 0.541, negative 5.54, and at x equals 2. And so we can use our calculator then to be able to find those. Now, it says here for step number 4 here, if g of x has degree 3 or greater, use the bounds test if possible to find lower and upper bounds for the zeros of g. Now, one of the things that, if you remembered when we talked about multiplicity in Algebra C, and we'll do that again today, or later on in this chapter, that for finding this 0 here, that because of the way the graph acts, it actually has a multiplicity of 2, which means then we actually probably could have factored this one, right? And when we get to multiplicity, we'll actually talk about that.